This is a short video about reactivity series of metal and properties of ionic compounds. You know, some metals are reactive, some metals are moderate reactive, some metals are least reactive. So they have been arranged, okay, in a column. Excuse me. In order of their decreasing reactivity. Okay, the most reactive metals are at the top, the moderate reactive metals are in the middle, and the excuse me, and the least reactive metals are at the bottom. So the first one is potassium. This first one is potassium. Then it is sodium, then calcium, then magnesium, then aluminum, then zinc, then iron, then lead, and this is then after hydrogen. Okay, hydrogen is a non-metal, and this has been placed among the this reactivity series of metals. Why this hydrogen, which is a non-metal, is in this group, I will tell you later on. So after hydrogen is copper, then mercury, then silver, and the gold. It is here. It means that potassium is most reactive and gold is least reactive. Okay, now look here. Just I am writing it in a board to show you. So first is the potassium. Let me write here. This is potassium, K, sodium, then calcium, then magnesium, then zinc, then iron, then it is lead, then hydrogen, then it is copper, then mercury, then silver, and at the end it is here gold. The end it is gold. Just look at this, watch it. This is at the top is the potassium and the bottom is the gold. This is gold here now. So they have been placed in this order. Side potassium, then after is the sodium, then calcium, then magnesium, then aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold. So potassium is the most reactive and gold is the least reactive metal. So this reactive metal is available in almost all the book. Now the question is that why is this hydrogen, which is a non-metal, in this reactivity series? It's because now look here. The reason is that the metal above hydrogen, the metals above hydrogen, they can release hydrogen from acid, right? Okay, so the metals above hydrogen, they can produce hydrogen gas when they react with acids. It's okay. And the metal below hydrogen, they cannot displace hydrogen from an acid. So this is the reason why this hydrogen is there. So did you understand? So hydrogen, a non-metal, is in this reactivity series of metal because the metals above hydrogen, they can release, they can produce, they can displace hydrogen from the acids, and the metals below hydrogen like copper, mercury, silver, gold, they cannot displace hydrogen from acid. This is the reason. So so the most reactive metal is potassium. Next comes the sodium, calcium, magnesium, aluminum, zinc, iron, lead. And then hydrogen. So these metals above hydrogen up to lead, they can displace hydrogen from an acid. And one more thing about this reactivity series is that the metals immediately above the other one can displace, okay, the metal below from the aqueous solution. Okay, do you understand? The metal, okay, above, okay, the metal above another metal can displace the metal just below it from this aqueous solution. For example, potassium can displace sodium from its salt solution, from its aqueous solutions, salt aqueous solution. Sodium can displace calcium from its salt aqueous solution. Okay, we have very familiar example we have seen in the classroom that iron displaces copper from its salt, from aqueous salt solution. Iron can displaces copper. It's okay. So like this it is here. Just I'm showing you the experiment. This is very common experiment. This iron, iron in the solid form plus copper sulfate, which is blue in color, aqueous form. So when they react to form ferrous sulfate in the aqueous form and the plus copper in the solid form, it is here. So okay, this is a displacement reaction. So like this is the reaction now. Like iron is above copper. Iron is above copper. So this is the copper case, copper sulfate. It is a solution of copper sulfate. It's aqueous. Aqueous means water mixed. So when iron is above copper, so iron can displace copper from its aqueous solution. Okay, so we get now like here, this is copper sulfate, and this is the copper you are getting here. This is the copper. So copper is displaced. The color of copper sulfate is blue in color. The copper sulfate is blue in color here now, blue in color, and so the blue color of the solution will become green in color because the copper sulfate is green in color. Therefore, the solution will become green in color. Okay, is it clear? Yes. So this is about activity series. So I think the video is going to be a big one. It is here. So just I am stopping it here. The properties of ionic solution I will show. Okay, I will tell you in some other video.